Hello everyone, welcome back to another video. I hope you're all doing well. Now in this video, this is like the final part of the topic 5 series that I have been going on. Before this, I was in a topic 1 series and now I'm doing a topic 5 series. So in this topic 5 series, just to summarize for you guys, if you're watching this for the first time, I covered how to calculate enthalpy change using bond enthalpies, how to calculate enthalpy change using enthalpies of formation, how to calculate entropy, which was a previous video, and now I'm going to uh, tackle how to calculate Gibbs free energy using enthalpy change and entropy and temperature. So there's a formula for this. And here is the question in front of us, and it's from the IB Chemistry Paper 2HL from May 2018, and it's from the Time Zone 2 batch. Now, this part, this part, we had already solved it in the previous video. So if you haven't watched that video, if you would like to see how I solve or how I calculate entropy and what entropy really is, please go back and watch that video. It's not too long. It's only about, I think, 9 minutes. And I give you a very good understanding, hopefully, of what entropy is and that you understand really what are we measuring over here. So please go and watch that video before watching this if that interests you. But now, today we're going to be taking a look at this part. And I took this whole screenshot because I just wanted to give you guys some context for the people watching for the first time. That's why I didn't cut this out. But I have actually already solved this question in the previous video. So please go and solve it. Watch it. And in this video, we're going to be taking a look at this part of the question. Now, I'm just going to write the answer for this over here because we're going to need it. I calculated this in the previous video. It comes out to be 216 joules per kilo. And now we move on to the next part. So they're asking us, calculate the standard free energy change, which is delta G, which represents change in free energy, delta G. Anything with delta represents change. I mentioned this in my previous video as well. And they're asking us to calculate it in kilojoules for this reaction at 298 Kelvin using your answer in B2 as well. Now, what is B2? Of course, I haven't put the screenshot here, but in this paper, B2 is the question which asks us to determine the enthalpy change of this specific reaction using enthalpy of formation values. Now, obviously, I'm not going to show you how to do that again because we have already solved enthalpy of formation questions before. Just 2 videos ago. So please check that out if you would like to see how I do it. But I've already calculated what the enthalpy of formation value will be for this reaction. And it comes out to be 205. So the enthalpy change value is 205. The entropy change value is 216, as I showed you above. And the temperature is 298 Kelvin. And remember, for this formula, we need temperature in Kelvin. Now, what is the formula to calculate change in Gibbs free energy? Let's get to that. The formula is very simple. I'm sure that this formula is available in the data booklet, but I would highly recommend you to memorize it. It's very small, very simple. In order to calculate standard free energy change using these values that I have written over here, the formula is enthalpy change minus temperature times delta S, which is change in entropy. And sometimes you'll see this formula being written like this. It's the exact same thing. This just signifies I've just opened and expanded this sort of here above because it's temperature times delta S, which is change in entropy. So that is it. That is the formula. Hopefully you understand what this is, and hopefully you're not going to get too confused. Now, all we have to do, if we know the value of each of these variables in our equation, we just have to substitute them in and we'll get our answer. So, well, let's do that. Delta G is going to be equal to the change in enthalpy, which is 205. And if you're wondering how I got that 205, I calculated it behind the scenes. So I've got it before I started to make this video. It's actually asked in another question. We're required to calculate the enthalpy in another question. That's why they've asked us to use the answer in B2, but to avoid the length, I have just calculated it for you and I'm using it now in the video because this video I'm going to focus on how to calculate Gibbs free energy. So delta H minus the temperature, which they've told us is 298 Kelvin. Please remember, temperature should always be in Kelvin for this equation, times the change in entropy, which is 216. Now, at this step, you may think that we just do this and we plug it into our calculator and we get our answer, but not so soon. You have to make one small change. Gibbs free energy or change in Gibbs free energy is actually calculated in kilojoules per mole. We have calculated enthalpy change in kilojoules per mole, but entropy, this entropy is actually in joules. It's not in kilojoules. So we need to convert from joules into kilojoules. So how do we do that? Well, it's very simple. In order to convert from joules to kilojoules, we just have to divide by 1000. So we divide this by 1000. And this will give us our correct answer. This will give us the answer in the units that we are looking for. This is a very crucial step. Don't forget to do this, because if you forget to do this, your answer will be wrong and you will lose the mark. So remember, you have to divide by 1000. You have to divide the entropy by 1000 to convert it from joules into kilojoules, because in IB, right, for some reason, they have told us that we should calculate entropy in joules. But when it comes to Gibbs free energy, we have to calculate that in kilojoules. And we already calculate enthalpy change in kilojoules, so we don't need to change that. However, for entropy, we calculate it in joules. So we have to convert it from joules into kilojoules. That's why we divide by 1000. Now, don't forget that step, very crucial. If you don't do this, the answer will be completely different. So please don't forget to do that. I've forgotten to do it many times and I've lost marks. So I just hope you don't make the same mistake. That's why I'm putting it out there. Now, when you plug this into your calculator, you will get your answer as 140.632. And you can approximately, if you want to give a whole number, you can round it to 141, but just write both answers in case. So the answer for this question, the change in Gibbs free energy is 141 kilojoules per mole. That is it. Now, why do we use Gibbs free energy? Why are we calculating it? Well, I'm going to make it very simple, keep it very simple and straightforward. I'm not going to get into the details because I'll be honest, I don't know much about it either. I have also only learned up to the IB syllabus. I've only learned chemistry up to the IB syllabus. I'll be learning more in university and maybe then I'll share it with you. But for now, I'm going to share with you what you need to know for the IB. What is the main purpose of calculating Gibbs free energy change? Well, we use it to determine if a reaction is going to be spontaneous or not. What is the difference between being spontaneous and not being spontaneous? Well, a spontaneous reaction occurs without any additional help. In very simple terms, that means the reaction will happen on its own, gradually or fast. Now, remember, spontaneous doesn't mean fast. A reaction can be spontaneous, but it can also be extremely slow. A spontaneous reaction just means that it happens on its own without any additional help or interference. So for example, like the formation of diamonds. The formation of diamonds could be considered as a spontaneous reaction because it happens on its own, but it takes millions of years for it to happen, but it can still be considered as a spontaneous reaction because it happens on its own, right? On the other hand, many reactions don't happen on their own. And that's why they are not considered as spontaneous. Now, spontaneous reactions can be fast, slow, medium. The pace doesn't matter. It's just about how it happens. It happens on its own or not. Hopefully you've got that. Now, how is this formula that I have taught you over here helping us? If the value that you're getting at the end is positive, so if change in Gibbs free energy is positive, the reaction is considered as non-spontaneous. So this reaction over here can actually be considered as non-spontaneous. However, if change in Gibbs free energy is negative, it is considered as spontaneous. That is it. That is the use of this formula, at least in the IB, and at least from what I know. Now, if you would like to do some more research, please feel free. Go ahead, do some research. Additional knowledge is always helpful. Let me know what you find. But otherwise, that is all that I know, and that's all from me for this video. Thank you so much for watching. If you have any other questions regarding this concept or any other concept, please feel free to message me on my social media. Put it down in the comments below, or send me an email and I'll be more than happy to help you. Thanks a lot for watching. I'll see you in another video with another question. Take care of yourselves.